Meet Allegro, the text-to-video model that turns your imagination into reality. From a simple text prompt, Allegro generates high-quality videos up to 6 seconds long at 15 frames per second and in 720p resolution. Whether it's dynamic scenes or creative animations, Allegro delivers with speed and precision, no complex setup needed. Just type and let Allegro handle the rest. Discover the power of text-to-video with Allegro, bringing your ideas to life one frame at a time.
So I gave it a go on 8 GB of VRAM, and here are some of the output. So for 10 steps, it took 1 hour on 8 GB VRAM. I guess more VRAM will reduce the processing time. And here is the output, which is not usable. Quality is not that great. And I understand that because they have suggested 100 steps. Now for 20 steps again, it was 2 hours. And here is the output, which is slightly improved. And here we have 30 steps output, which took around 3 hours, but output is much better. So I guess with 100 steps, the output would be pretty great. So this will help you take a decision whether you want to install and give it a go or not. And here is the VRAM consumption. So just read it as -1 because OBS Studio occupies 1 GB of VRAM. So it takes in between 6 to 8 GB of VRAM. And also you need a lot of hard disk space, free hard disk space, because around 30 GB it needs for quantization. So I have tested this on 8 GB of VRAM, 16 GB of RAM, and around 40 GB of free hard disk space. So before proceeding to the installation, please understand the memory requirement for this was very, very huge. Like to achieve an inference time of 3 minutes, they have suggested to use 8 H100 GPUs, which not everyone can afford. And the reason being is the resolution is very high. So I just wanted to test the output on 8 GB VRAM. So I've finally been able to make it work, but everyone have basically mentioned in the issues section that even 24 GB is not sufficient. So it works, but it is very, very slow, very slow. So on 8 GB of VRAM for 6 seconds of video with 10 steps, it takes 1 hour. So maybe if you have a good VRAM, maybe 24 GB VRAM, you can try that and see if the processing time reduces. Otherwise, I don't think it is necessary to install this. I'm just basically compiling this guide so that if anyone wants to test on low VRAM, they can do so just to see the quality of the model. So this is the new compiled repository. Don't ask me where all these source files have gone. We only need this one for Gradio and this one for command line. So let's start with the installation. So this is the installation guide. And please understand, Triton is needed for this installation. So for that, we will have to use the wheel. So these are the standard steps where we open a command prompt. Let's start by cloning the repository. Next, navigate inside the clone repository. Now we have to download the wheel. So just copy this link. And from here, you can copy the wheel. We will use 3.0.0 windows.post3. So just find this and download this wheel and put it in the Allegro folder. So I've already downloaded it. I'll just move it here. So inside the clone folder, you should see the Triton wheel. Now the next step is we will create the virtual environment. Please use only Python 3.10 for this because I have only tested on this. So if you don't have 3.10 installed, then use Conda to create the environment with Python 3.10. Otherwise, proceed with this Python virtual environment. So once the virtual environment is created, activate the same using step 5. Then we will first install the wheel package, and then we will install the requirements for Windows. While the installation is in progress, we can download the models. So mention the command, copy the command mentioned in step 8. For that, open a new command prompt and paste and enter this command. So all the models will be downloaded in this folder. Now, once the installation is complete, we will have to install Diffusion library from the source. So after this, the installation will be complete. So paste the command and press enter. Now this completes the installation, so you can close the command prompt window. Now to launch, first I will explain how to use for that, open the command prompt, activate virtual environment. Now open this file in any text editor. So scroll down where you see this prompt. This is the prompt which you can update with your own prompt. You can also change the positive prompt and negative prompt. Make sure this is a template. So do not remove this because it will be automatically replaced by this prompt. And after that, you have to update the number of inference steps. So they have suggested 100 inference steps. Now, depending on your GPU, you can try even lower. I've already shown the output, how each of these steps influence the results. So to use this, once you have made the changes in the file, you can simply use Python quantized inference.py and press enter. This will download some additional models in the runtime, but that only happens for one time. Now to launch the Gradio based UI, you can use Python app.py. Make sure the virtual environment is active and press enter. So this will take some time. Each time it will take some time to quantize the models before launching the web UI. Now, once the server is started, you will see it is running on local URL. You can just control click on the link and it will launch the Gradio based web UI. So UI is pretty straightforward. This is where you put the prompt. Here you can put positive prompt. Here negative prompt. Make sure if you update this whole section, this should remain intact. Then here you can place negative prompt. This is the guidance scale. Now I don't know what does this max sequence length does. I have not tested with different values because this model takes a lot of time. Now this is where you can select the inference steps. And this is the seed. If you keep it -1, it will randomly generate the seed. Otherwise, you can put any number for seed which you want to use. And then click on generate video. So you can try if you want to. Just give it a go and review the output of this model. That's it for this demo. Thank you.